Hello, Math 119 students. In this video, we're going to do more confidence interval simulations. And in the first video, we demonstrated what's the meaning of the level of confidence. This video, when we do a t-interval, we have some requirements. So these are the three requirements we have right here. I want to specifically look at the third one, which is the central limit theorem requirement. So I want to demonstrate what would happen if this requirement was violated. The third requirement says either the sample size is at least 30 or the population distribution is approximately normal. That's what we need to set to satisfy the central limit theorem. So what if this requirement is violated? How would that affect our confidence intervals? So let's look at that. So in the first video, we looked at basically this one. We had a normal population with a mean of 50 and a standard deviation of 10, and we had looked at a small sample size with confidence level 90% and 99%. This time, if we have a small sample size, but we're going to look at a right skewed population. So the third requirement says you either need to have a normal population or a large sample size. Now we have a non-normal population and a small sample size. So we are violating the third requirement for the central limit theorem. So let's see what happens when we do a simulation from a non-normal population with a small sample size. Then we'll change it to a large sample size, and we'll see if that makes any difference. So here's what we have. We have a right skewed population, the mean of 50, standard deviation of 10. We simulated 100 confidence intervals, and our confidence level is 95%, so we would expect to have 95 out of 100 to be green, and we got 93 out of 100. So that's not too far off. Let's look at 1,000 intervals. Okay, so now we're a little bit below 95%. We got 90.73% that were green. In other words, 90.73% of the confidence intervals were intervals that contained the true value of the population mean. Those are the green ones. The red ones are the intervals where the true value of the population, the true mean of the population, is not contained within the confidence limits. Like if we look at this red one here, I'll put my cursor right there. This red one, the upper limit is 94.624 and the lower limit is 42.2529. That one does not contain 50. So the red ones are the ones that are, in other words, you can think of them as inaccurate. They do not contain the true value of the population mean, which is known when we do a simulation like this. Okay, the green ones are the ones that do contain the true value of the population. So we have 90 out of 1,100, we have 90.73% that contain the true value of the population, and we expect to have 95%. So we're a little bit below. Let's do 1,000 more. Okay, so now we're 90.62% green. And we expect to get 95. This time, what I want to do is I want to increase the sample size. So if we increase the sample size, let's make it 35. So if we increase the sample size, now, even though we have a right-skewed population, by having a large sample size, we are satisfying the third requirement. Because it says the third requirement says you either need a normal population, or a large sample. So now we have a non-normal population, but we have a large sample. So we should have fairly accurate results here. So let's check it. Let's do 1,000 intervals. So we have 95% confidence level, and we got 92.3 out of 1,000, 923 out of 1,000. That's 92.3%. So we're still a little bit below. Let's do 1,000 more. Okay. So now we have 90, close to 94%. 1,859 out of 2,000. So I think we're a little bit more accurate, more closer to 95% than we were when we had the small sample, which is what we'd expect. Okay, so uh, the results weren't that dramatic. We didn't have 95% confidence interval, and then we have only 85% of them were green. It's somewhat close to 95% we got in our results for both small sample and large sample. The large sample was a little bit closer to 95% than the small sample. Okay. But anyway, so hopefully this helps you to understand why it's important to satisfy the third requirement and why we have those requirements in the first place. So that's all I wanted to discuss in this video, and that's it.